Hi everyone, this is Aime Ii. Welcome to Math at All. Today we will be solving 2017 Aime Ii problem number 11. Let's look at a question first. And meanwhile we are reading the question, let's underline the keywords. Five towns, this is already a keyword. 5 towns are connected by a system of roads. There's exactly one road connecting each pair of towns. This is important, right? One road, each pair. Find the number of ways there are to make all the roads one way. Okay, here is tricky. It's one way, right? The roads nowadays are two ways, but in this question, the roads can only be one way. So let's say this is town A and this is town B. If A goes to B, then B cannot go back to A because in the question, it says that the road could only be one way, in such a way that it is still possible to get from any town to any other town using the roads, possibly passing through other towns on the way. Okay, so we've gathered the information from this problem. Even though this problem is very short, but we're still going to use the essence provided in this problem to tackle the question. Okay, so to start off, I want to clarify two terms. The first one is loop, and the second one is configuration. Configuration. Yep, I think that's how you spell it. But anyways, so let's explain loop first. And I'm pretty sure that most of you already know what loop means, right? It's just something that connects things, right? So that basically they're connected. The things are connected through a loop, right? And in this question, that's exactly what it means. So let's say town A, town B, and town C. If A goes to B, B goes to C, and C goes to A, this forms a loop, right? Because they're just inside a loop that connects them together. And configuration. This word might sound very high skilled, but actually in this question, it only means the structure of the roads. Okay, it only means the structure of the roads. Like in what kind of combination can the 5 towns be connected by the roads? So let's use an example again. Again, we will use 3 towns. So A to B, B to C, C to A. This is one configuration. Again, A, B, C. And this could be another configuration, right? It's just like how the system of roads will look like. That is what configuration means in this video and in this question. Okay, so yeah, and other than that, for configuration, we'll also define something called bad configuration and something called good configuration. What is a bad configuration? A bad configuration is simply a structure of the system of roads that does not satisfy the problem. And a good configuration, as you might guess, is just a configuration that can satisfy the problem, the conditions given by the problem. Okay? So bad and good configurations. We're going to talk about that later anyway, but it's important to note out these terms first. Okay, and for loop, I wanna point something out. Something else is also important about loop, which is, let's say there are 3 towns, A, B, and C, and they are in a loop. If there's another town called D, and D says, "Oh, I really want to join this loop. I want to be their friends." So D chooses to have its road pointing towards B. Okay? And in the question, what does it say? There is exactly one road connecting each pair of towns. What does that mean? Well, that means in between each 2 towns, there has to be one road, right? Exactly one road. And the roads are one way, correct? So from the perspective of town B, it cannot have its way point to A because A already points to B. It points to C already, and it cannot point to D because D already points to B. Let's think about A. For A can point to B, right? A is already pointing to B. A cannot point to C because C is already pointing to A, and A can choose to point to D, correct? And C is the same thing. It cannot point to B because B is pointing to C, it already points to A, and C can choose to point to D, correct? So what I want to try to say here is that whenever an element here really wants to join a loop, then his dream will actually come true, correct? If he, the town D, wants to enter this loop, then his dream will be satisfied, okay? This is going to be very important in the later explanation, so just keep this in mind, okay? So whenever there's a town that wants to enter a loop, then this town will actually join the loop. Okay, so enough of the definitions, let's proceed. We are going to talk about different cases, like the different types of configuration. I already drew them out. So let's talk about case number 1. So what do you notice here? We have 5 towns, right? And case 1, obviously, as you can see, all the other towns except for the town in the middle are pointing towards it. So case number 1, it's 4 towns pointing at the 5th. Okay? So 4 towns pointing at the 5th. Now we're going to talk about whether this is a bad configuration or good configuration. Well, it's definitely a bad configuration, right? Why? Well, it's because the town in the middle that is being pointed towards really wants to go out and find his friends, right? He wants to have connection to town A, town B, town C, and town D, right? But since all the roads are one way and all the other towns are already pointing at this center town, he cannot go out, right? So he cannot have any connection to A, B, C, and D. Therefore, this is a bad configuration. Let's say this is a bad configuration. Bad. Okay? Okay, move on to case number 2. This is very similar to case number 1. Well, except this time, this town, the center town, is pointing outwards. It's pointing, it's having all of its roads leading out to other towns. Well, this is also a bad configuration, right? Why? It's because it is pointing to all the other towns. No towns are going to point towards it, right? So this is going to lack connection at the end, right? So let's say if this is A, this is B. A cannot find a way to access B, correct? So this is also a bad configuration. Okay, let's move on to the third one. So this, okay, I drew this in a shape of a pentagon so that it will look better. Well, as you can see, all the towns are forming a loop, and in this loop there are 5 towns, right? So this, what can we say? This is a good configuration, correct? Because this town can get to this town can get into this town. All towns can get into whichever towns they want, right? Because there's a loop that connects all of them together, and each town in the loop can have access to another town in the loop. So this is a good configuration. Let's move on to case number 4. What is this? Well, as you can see, this is a loop of 4 towns, right? 1, 2, 3, and 4. Well, from case number 3, we can already say that these four towns in the loop can access each other, correct? But how about the middle one? How about the lonely one in the center? Well, here, this time, this logic will be applied. As already said, if one town in this question, one town wants to access the loop, it chooses to enter it, then it's going to make it, right? It's going to make the loop, and this will result in a good configuration. Because this town, the town in the middle, has to point out to one of the towns in the loop. It's going to join the loop and have itself being accessed, or having itself being able to access all the other towns, correct? That's the conclusion we derive. We derived from this logic. Okay, case number 5. This might be a little bit tricky. So we divide it into subcase number 1 and subcase number 2. For subcase number 1, we see that there's a loop of 3 and there are 2 lonely elements here, 2 lonely towns here. And for the 2 lonely towns here, I set this one to be A and the other one to be B. And I let A point towards B. Okay, so if I let A point towards B, then something interesting is going to happen. So B has to find something else to join, right? So, but it cannot join A back because this road is a one-way road, so it has to join a town in the loop. So let's say it joins this element, okay? And so B will enter the loop. However, what about A? What about A here, this A here? It has to have a town that connects to A. Is it correct? So because A point towards B, B cannot point towards A back. So one of the 3 towns, or at least one of the 3 towns in the loop, has to have its road directing towards A. Let's say this, okay, this town over here. So in this case, it's forming 2 loops, right? Here's one loop and here's another big loop, correct? So what can we say? This is actually a good configuration, correct? Because we're forming loops. We're having all our elements inside loops. And it's the same logic for subcase number 2, except B is actually pointing towards A. So this is also a good configuration. Okay, now we've gathered all information about the cases. Now we're going to do the calculation. And as already said, we are going to use bad configuration and good configuration. So we're going to calculate the number of good configurations, right? So it says here, find the number of ways there are to make all roads one way. So that means we're calculating for the good configurations. Good configurations. What is one way to calculate the good configurations? Well, you probably might realize that if we count the total number of configurations, then this is equal to the number of good configuration plus the number of bad configurations, right? And if we were to rearrange the equation, we'll get good configuration equals total configurations minus bad configurations. Okay, so how many total configurations do we have? Think about this. There are 1, 2, 3, 4, 5 towns, right? And we're going to have exactly one road in between each pair of towns. So how many towns can we choose? How many combinations, how many pairs are there in this system of towns? It's going to be 5, choose 2, correct? There are 5 to choose number of roads. There's 5 choose 2 number of roads. However, each road can point toward and away. So there are 2 choices for each road. That means it's 2 to the power of 5 choose 2. Correct? That's the total number of configurations. 2 to the power of 5 choose 2. Now let's count the number of bad configurations. So what do we know about the number of bad configurations from our analysis of the cases? Case number 1, case number 2, yeah, so only case number 1 and case number 2 are bad configurations, correct? So we're going to subtract the bad configurations, which are case number 1 and case number 2, from the total number of configurations. So case number 1, let's move this. Let's copy and paste this one down. Actually, no, we don't need to copy and paste. I'll just draw another one. Case number 1. What is case number 1? Case number 1 is having all other 4 towns pointing towards the 5th town, right? How many ways are there to have the town being pointed towards? There's 5 different towns, so there are 5 ways to choose the town that is being pointed towards. And because this is, or we already know this is a bad configuration, it doesn't really matter how the roads are assigned in between A, B, C, and D, right? Because this is already a bad configuration, so the roads can be randomly assigned between A, B, B, C, C, D, and D, A, and A, C, and B, D. So these 4 towns, A, B, C, and D, can have their roads being randomly assigned. Okay? So how many ways are there to do this? Well, there are 2 to the power of 4 choose 2, right? 4 is the number of towns. There are 1, 2, 3, 4, 4 towns. And 2, what does 2 mean? Well, 2 just means you're choosing 2, right? So there are 4 choose 2 number of roads in between town A, town B, town C, and town D. So 2 to the power of 4 choose 2. And it's going to be the same thing for if the town in the middle is pointing outwards to all the other towns, correct? It's going to be the same answer as this. I'll just omit the calculation, but you can do it on your own. It's the same as 5 times 2 to the power of 4 choose 2. So at this point, you can say that good equals to, how many total configurations are there? 2 to the power of 5 choose 2 minus 5 times 2 to the power of 4 choose 2 times 2, correct? Well, however, you might be tempted to end the calculation here. However, this is not the final step. We are actually overcounting cases. Okay, we're actually overcounting cases in between these 2 bad configurations. Well, what do I mean by that? Okay, I will make a new system of towns. I'll use another color just for clarity. 1, 2, 3, 4, 5. Okay. So let's say this is A, this is B, this is C, this is D, and this is E. And we are having all the towns pointing towards A, okay? This is the type of bad configuration from case number 1, right? It is this bad configuration. However, you may also notice that something else can happen at the same time. Well, let's choose B, okay? Let's say B points towards A and it also points towards E, C, and D, right? We are able to satisfy both types of bad configurations at the same time. And we're overcounting them, right? So we are going to subtract the number of cases that are being overcounted. But how many of them are there? Well, let's follow the same logic again. There are 5 towns, right? So there are 5 ways to choose the one that can be pointed towards. So that leaves four choices to have the number of towns being pointed outwards, correct? So this is towards, and this is outwards. And we are left with three remaining towns, okay? And you can randomly assign the roads in between those 3 towns because it doesn't really matter which configuration that the remaining 3 towns they're in. And so we're gonna have 2 to the power of 3 choose 2, right? And that is going to be the number of overcounted case. So we're going to actually minus the number of overcounted cases. So this is the actual expression for the number of good configurations. And if you were to calculate it, the number of good configurations will be 544. Okay? So yeah, that is one way to solve this question. I hope that this video will help you out, and I'll see you next time. Bye!